Assalamualaikum warahmatullahi wabarakatuh, and hi everybody. Now what I'm going to discuss now is about the integral solution for Fourier series. And before that, make sure that all of us now really understand about functions. And we also know how to identify the t, the omega, the boundary, and also the relevant ft based on the given function ft. And now let's have a look on this question. Okay, this question has been discussed before with the example that t not equals to 2 pi. Okay, so now we would like to discuss only how to obtain the Fourier series expansion, because for the sketching we have already done. Okay, and after this I'd like you to have this question with you now written, or you copy it now, and after this we will discuss on how we can do the integral and find the Fourier series expansion. Okay, so now we already knew that ft here equals to 0 for t starts from -2 to 0, and 1 for t starts from 0 to 2. Okay, and from the question we already knew that the t equals to 4, the omega equals to 2 pi over 4, hence equals to pi over 2, and the relevant boundary is, since we have 0 here, so no need to integrate here. So what we will consider is only this one, where we have 1 and dt here. So here we have 0 to 2. Okay, so that's only the thing that we should know now. Alright, so next what we like to do now is to find the a naught. Okay, and the a naught is given in general as this one. Correct? Okay, now based on this, we will plug in all the values of t, the boundary, and the ft inside the equation a naught. And after this, we solve the integral, and we have t start from 0 to 2. So here we have 1 over 2, 2 minus 0, so we have 2 equals to 1. So a naught equals to 1 is the solution that we have for now. Then what we will do next? Next is to find the an. So an is given by this equation. So here we need to multiply the ft with the cos and omega t dt. So now when I plug in all the values, I have 2 over 4, 0 to 2, 1 cos, and pi over 2 t dt. Okay, when we want to solve the cosine integral, we should know the basic of this cosine integral. And what we can see here from this example, this t is now multiplied with n pi over 2. So we can consider this like cos a t. Okay, so for any cos a t dt, the integral of this one will result to sine a t over a plus c, right? So this is in general how we can solve this one. So if we knew about this, then I delete this one and I continue now with a equals to n pi over 2. So now I have 1 over 2 sine n pi over 2 divided by n pi over 2, 0, 2. Okay, so this is what we have now. Okay, after that, what will we do is now to plug in all the values of 2 and 0. Okay, before that, sorry, I should have t here, right? Okay, so I will now change the value of t with 2 and after that with 0. Okay, so what we have now, this is an equals to half. So since we have now sine n pi t over n pi over 2, so I have now 2 over n pi. Okay, and we have sine n pi over 2 multiply with 2 minus sine n pi 0 over 2. Right? Okay, so since we know that any sine 0 is 0, so we only have this. And we have now 1 over n pi sine n pi only. Okay, so we have sine n pi. Okay, now there is a question now. Okay, what is the value of each of these sine n pi when it is multiplied with 1 over n pi here? And what we know actually from this definition that the value of n here is defined as 1, 2, 3, 4, and so on and so forth. Okay, so now for the an equals to 1 over n pi sine n pi. Okay, we can now identify first what is the a1. A1 is when n equals to 1, so we have 1 over pi sine pi. So sine pi equals to 0. A2 is when n equals to 2. We have 1 over 2 pi sine 2 pi, which also returns to 0. And if we replace the value of n with 3, 4, 5, 6, so on and so forth, what we will have is actually also 0. So what we can conclude here, the an equals to 0. So in this case, the an equals to 0. Okay, then next we want to find what is the bn. Okay, bn is defined as 1 over bn is 2 over t d to d plus t ft sine n omega t dt. Correct? Okay, now I should put here dt. Okay, so now when we plug in all the values, we have here sine n pi over 2 t dt. So the same thing now, if I consider this just like a, okay, and if I have sine at dt, it will give me negative cos at over a plus c, correct? So based on this integral, I can now solve this bn. So I delete this one